Radicals can be split up using multiplication and division. For example, the square root of 45 can be split up into the square root of 9 times the square root of 5. It could also be split up into the square root of 15 times the square root of 3, but we can't do the square root of 15 or the square root of 3 without getting decimals. I chose 9 and 5 because what is the square root of 9? 3. So this becomes 3 times the square root of 5. The square root of 16 25ths, we can split that into the square root of 16 over the square root of 25. The square root of 16 is 4. Square root of 25 is 5. So that becomes 4/5. I left this slide in your notes so that you can see kind of what we're attempting to do. However, I think that their method for finding perfect squares is a little not as easy as some other methods we can look at. So if we take the square root of 75x to the 5th, we can take the square root of 75 and split that into the square root of 25 times the square root of 3. So 25, that's the perfect square portion. 3 is the leftover factor. We can take the square root of x to the 4th and split it into, well, keep in mind from previous lessons, this is the same thing as x to the 4 over 2. 4 divided by 2 is 2, so that's going to become this x squared right here. So if this is an even index, they want to group those x's into evens. So we've got the square root of x to the 4th, that's an even number, so we can simplify it, and the square root of x, that's the leftover portion. So we end up with the perfect square portion and the leftover portion. Honestly, this seems like the confusing way to do it, so let's do this in an easier way. The square root of 144x squared. We've got the square root of 144, and we've got the square root of x squared. What is the square root of 144? Do any of you know? 12? Square root of x squared. The square root and the square cancel each other out, so that's just x. So our answer here is 12x. Now let's look at one that takes a little bit more work. I'm going to draw a line right here and then write this stuff up here so I have a little bit more room to do work. I've got the square root of 8 and the square root of x to the 3rd. We need to split up the square root of 8 into 2 square roots. We really want this first one to be a perfect square that we can actually evaluate. So perfect squares, 1, 4, 16, 9, 25. What should we split 8 into? 4 times 2. The square root of 4 is 2. So we have 2 times the square root of 2. That is our number portion of this problem, 2 times the square root of 2. The square root of x to the 3rd, we can split that into the square root of x squared times the square root of x. Do you all see that there are still 3 factors of x under the radical? Yes. 2 of them under the first one and 1 of them under the second. The square root of x squared is plain x. So our variable portion of this is x times the square root of x. To write our final answer, we put the 2 and the x that are not under the radical. We put those first. No, don't go to the next slide. Just highlight what I asked you to highlight. There we go. Then we put a radical, and you put the stuff that's left under the radical. The 2 and the x that are stuck here under the radical. Now, there are a couple ways to think about simplifying the square root of x to the 3rd. One way is to split it into the x squared and the x and then simplify it. Another way to think of it is how many groups of 2 are there in x to the third? If we've got 3 x's, do you remember elementary school when you had like beans on the desk and the teacher asked you to split the beans into groups of 2? There is one group of 2. That group gets to break out and become a plain x, and this one is still stuck under the radical, sad and lonely. In my Algebra B class, I teach them that this is a square root prison, and these 3 x's are chilling in prison, and they can break out in groups of 2. So one group breaks out, and one person gets stuck inside and doesn't get to leave. I know, poor dude. But you could, or yeah, dude or dudette or whatever. You could think of it as like these 2 had like a minor traffic violation, and this one like, you know, murdered, killed a kid or something. So, I mean, they should probably stay there, right? Maybe that's not for us to say. I don't know. Okay, this one, we have the square root of 18. We have the square root of y to the 7th. I'm going to leave some space underneath those so that we can do some work. And on the bottom, we have the square root of x to the 10th. What? Seriously, slide. Stop moving. Okay, square root of 18. We want to split that into 2 square roots. We want one of them to be a perfect square. What number is smaller than 18 that is a perfect square? 9. 9 times 2. So we have 3 times the square root of 2. That's my number portion from simplifying the square root of 18. Square root of y to the 7th. I'm going to show you the long way to do this and then the shortcut. The long way is square root of y squared, square root of y squared, square root of y squared, square root of y. Is that 7 y's? 2, 4, 6, 7? Yeah. Okay. This one is a y. I'm so angry with this PowerPoint right now. You have no idea. This one's a y. This one's a y. And this one is a square root of y. That's y cubed, square root of y. The shortcut. How many groups of 2 are there in 7? 3 groups of 2 with 1 left over. I like to use dots because I'm a visual person and it's very easy for me to see the groupings. It's easy for me to see how many are left over. If you want to write 7 y's and then circle groups of 2 of them, I just like dots because it's super easy and quick and doesn't take up a ton of space. So these 3 y's become y cubed, and then there's that 1 y that's still stuck in prison. Square root of x to the 10th. How many groups of 2 are there in 10? 5. So that becomes 5 full groups that get to break out. Our final answer here, we've got 3. Oh my gosh. 3. I would really like it to just write a plain 3 without the craziness. Y cubed square root of 2y. And on the bottom, we have x to the 5th. On the next slide, example 2, I'd like you to try number 1 on your own. Pause the video. You're simplifying the square root of 120. You're simplifying the square root of x to the 8th and the square root of y to the 5th, and then putting all of that together into one cohesive answer. So pause the video, try this one on your own. The only perfect square that goes into 120 is 4. So we have 2 times the square root of 30. X to the 8th. How many groups of 2 are there in 8? 4. So we've got x to the 4th. How many groups of 2 are there in y to the 5th? There are 2 full groups of 2, so that would be y squared. And then there's still a lonely y stuck under the radical. So see how by using the dots like that, I can visually see my 2 full groups and my 1 left over, but I didn't have to show a ton of work. As an answer, a final answer, we write 2x to the 4th y squared, then our square root of 30y. Seriously, I'm going to smash this thing. You didn't hear that on the video. I mean, I know you did, but you didn't. Next, we need to do the cube root of 54, x to the 5th, y to the 9th. This time, we are talking about the cube root of 54, the cube root of x to the 5th, and the cube root of y to the 9th. The most difficult part of this is the cube root of 54, because you need to think about your perfect cubes, which I will write a list of perfect cubes on the board. I will give you a list of perfect cubes for the test. Perfect cubes are like, let's see, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. We can split this into the cube root of 27 times the cube root of 2. The cube root of 27 is 3 because it's the 3rd perfect cube. Okay, now this is a little bit different for the x to the 5th because this time we're talking about the cube root. The cube root will cancel out x cubed. So we need to think about groups of 3. How many groups of 3 are there in 5? 1 group of 3. So 1 group gets to break out, and x squared is still stuck under the radical. How many groups of 3 are there in y to the 9th? 3. 3 full groups, so we end up with y cubed. You can also think of that as 9 divided by 3 is 3 with no remainders. Our final answer then is going to be 3x y cubed times the cube root of 2x squared. Try number 3 on your own. Pause the video. I mean it. Pause the video. You paused it yet? Okay, cube root of 40. If we think about our perfect cubes, which we've got a list right here, 1, 8, 27, 64, we can do 40 divided by 8 and get 5. So 8 times 5 is 40. The cube root of 8 is 2, so our number part is 2 times the cube root of 5. How many groups of 3 are in 8? There are 2 full groups with 2 left over. Cube root of w cubed, how many groups of 3 are in 3? 1. So our final answer, the stuff not under the radical, 2x squared, and then the cube root of 5x squared. On the bottom, we have the w. Your assignment is what's listed on your assignment sheet, except we are skipping number 50. So we are going to save example 3 for tomorrow. We'll do example 3 tomorrow. And then on your assignment, you can skip number 50, which leaves 9 problems for you to do, which is not too bad. Some of them are pretty simple.